All right, again, please take out your agenda, something to write with. Please, good morning, Katie. Please take out your agenda, something to write with, and take out your periodic table of elements. I'm going to type in the chat what it is that you need to have for me in your agenda. So in your agenda, please write Module 4.4 and 4.5 are due tomorrow. Module 4.4 and 4.5 are due tomorrow. Module 4.4 is the poster. I'm going to type it in the chat for you guys. Write this in your agenda. And module 4.5 is the quiz. Going to admit a couple of more people. Okay. Module 4.4 is the poster and 4.5 is the quiz. Then what you need to write in there is module 5 is due by Friday. Oh, it didn't come out. Okay, module 5 is due by Friday. So I want to share my screen with you guys. I still have people coming in. We'll give them a couple of minutes. So it's 11:32. Give everybody a couple of minutes to get in because I only have 23 participants as of right now. Some of you may be finished with the poster. Some of you may be finished with the quiz. Some of you may be finished with module 5 too, or module 5 altogether. I just want to go over a couple of things with everybody in the class so you're all aware and you're writing this in the agenda. Good morning, Addie. I'd also like to welcome Ronald. I don't know if you go by Ronald or if you go by Ron. You can unmute yourself and introduce us, or you can type it in the chat. Say it again.
I got to be called Ronnie.
Ronald. Okay, you got it, Ronald.
Ronnie.
Oh, Ronnie. I'm sorry. Okay, Ronnie. We've got Ronnie. So everybody, please be aware that we have a new student joining us. He's not new to Balboa, but he's starting back up again. So we have Ronnie in class with us. Okay, I'm going to share my screen with you guys. I'm going to turn off the chat for a minute. Share my screen with you guys. And we're going to go into, hang on a second, because I have to open it up. Okay, we have Canvas. And in Canvas, we are in period 6, right? So in period 6, you have modules 4 and 5 open to you. Besides module 0, module 0 will always remain open, right? Because it's all the how-tos, how to download or submit using a link, download a file, everything like that. And it has my syllabus in there. We're at module 4.4, which is the poster. When you get to the poster, if you've not been there already, you're going to talk to me in the poster. And what I've done, which you might find helpful, is that I have actually, here's your poster, right? And the requirements for the poster, I've actually printed out my requirements, right? So when you're completing the poster, you can check off everything to make sure that it's on the poster as you're being asked. Now, just because it's a poster, it does not have to be huge poster size. I've already explained that. You can use the paper that you were given in your book bag when you came to school the first day, right? And in there you were given colored pencils, you were given a highlighter, you were given a Sharpie, you were given a bunch of things that you need for the year. And you can create that poster on a piece of the paper that was in your book bag when you got it. You don't have to go out and get anything. I do not require you to go out and buy anything. You can use everything that you have. So the poster is something that you're going to complete by tomorrow. Now, this is a small example. but this does not contain everything that it needs to contain. So your poster is due tomorrow by 11:59 p.m. as well as the quiz. The quiz asks you 5 questions, right? And the 5 questions that it asks is like, what is matter? What is an atom? It's not asking you for an example of an atom. It's not saying, tell me, an example like lithium is an atom. I want you to tell me what an atom is made up of, what an atom is. The poster, I want you to make sure that you go through that whole checklist. Okay, I'm going to show you an example, and now I have 2 examples, and they just happen to be from this class. So I am going to stop sharing right now because I'm going to open up one of the examples, but I don't want you to see the name that is on the example when I open it up. So I'm going to go into, this is period 6, and I'm going to go into one of the posters that has everything. Now, mind you, I am not an artist, right? I do draw stick figures, and I am not somebody that has great drawing skills. I like to try, but that doesn't mean that I can draw really well. I'm going to open up one of these posters, and I am going to hide the name so you cannot see who it belongs to. And I'm just going to explain some things to you that are in this poster that I would like to see on your posters, because it has everything that I am asking for. So when you look at this poster, on the poster here, it shows you that I asked for a title, right? And the title that I asked for is here. It says states of matter. I asked you to define a solid, a liquid, and a gas, and they're all defined here with the drawings as well. These drawings show that the atoms for a solid are tightly packed together. Atoms for a liquid are more loosely packed than those of a solid, so they have movement. And atoms for a gas, those molecules are bouncing off of one another. They are rapidly moving. There's a big space between all of them. So that's shown in those pictures, which is great. It also shows you here the definitions for vaporization, condensation, melting, and freezing. You needed to have those as part of the poster, as well as arrows. It asks to draw arrows between each phase change, right? It also asks for sublimation. So sublimation is when we go from a solid directly into a gas. Now, you needed to draw an arrow for deposition. However, I did not ask for a definition of deposition. This individual went in there and defined it for us and gave us pictures, right? I asked for 5 examples. So here are the examples of solids: books, rock, computer, wood, glasses. Liquids, this individual has a little sense of humor. They drew a cute little kitty cat here, and the kitty cat urinates. So that's the liquid coming out of the cat. Honey, water, Coke, a stain from a pomegranate juice, orange juice. And then the gases here: helium, air, carbon dioxide, fluorine, and neon. On this poster is everything that I asked you guys to add to the poster. So that is something that looks like a 55 out of 55. Multiple students are doing really well on this, but I just want to make sure that when you do it, you have the checklist in front of you and you can add the information that way. Are there any questions about what's required for the poster? If there are, you can either rename yourself, not rename yourself, you can either write it in the chat, or you can just unmute yourself and let me know what kind of questions you might have for the poster. Did Joshua have a question? Okay. Anybody have questions about the poster? Everybody's here now. So It is due tomorrow. That was a great poster. Yes, Samantha. I did get quite a few great posters in this class. Okay, good, Aiden. Thank you. I did get quite a few really nice posters in this class, great drawings, you know, but all the information is there. To me, that's what makes the great poster, is that everything that I asked for was in there. Ah, did it, Katie? Okay. Were we supposed to get posters before this or something? No, you do not need poster paper or anything, Thomas. You just use any paper that you have. I said that you can use the lined paper that you were given. You don't have to do that. Some people cut out pictures from a magazine and put it on the poster. Some people drew their posters. The only thing that I said is that I do not want you to create a Google slide or anything like that. I don't want you to cut and paste. I want you to actually create the poster. What do you normally do, Maddie? Okay, good, draw. Yeah, drawing paper is fine, Aiden, that's fine. Okay, good. All right, perfect. So we're good on the poster. Okay, next thing I'm gonna do is I am gonna share my screen again with you again, and we're gonna talk about assignments for module 5. Okay, so we're in period 6. Module 5, some of you aren't at module 5 yet, or you're not at the last assignment for module 5, and this is taking forever. Okay, period 6, we're at the dashboard. Module 5. With module 5, there are 2 assignments for module 5. Those 2 assignments include a discussion, okay? The discussion has to talk about the periodic table, how the periodic table is built, and we're going to talk about that today. And then comparing a periodic table to a closet, right? So you have to, in that discussion, you need to write 3 things in the period about the closet that is like the periodic table, okay? Then you need to respond to 2 students. And how do I know that? It tells me in the directions, right? Here's your periodic table. You're going to be talking about these 2 closets and the periodic table. What do these 2 closets have in common with the periodic table? In your discussion, identify at least 3 things. How many things? 3 things these closets and the periodic table have in common, right? Then you're going to respond to 2 other students. Now, it says in a polite manner. Some people have not been polite, and I'm pulling down their posts because they're not writing nice things, okay? Also, some people are writing, I agree, which is not a conversation, right? It's not a discussion. You need to write what you agree with or why you agree with it. If you're just writing, I agree, you're not getting credit for that. It's credit for 3 things about the closet and the periodic table, credit for 2 student responses that are complete responses. After you do that, the other thing that you have left to do is play a game, okay? Here's the periodic table activity. It says you must play 3 times. How many times? 3 times. After you play 3 times, you need to screenshot your score for how many games? 3 games, right? I want to see 3 screenshots, 3 games, and then submit them to me. You are going to play the games that when you play it, you're going to click on the symbol easy, and you're going to do common elements, which is medium. So down here is my link to click into the game. And I click into that link. And when I click to that link, it's going to take me right here. This is exactly where I want you to be. Let it load. Okay. If you have advertisements blocked, it's not going to load. So you need to unblock advertisements, right? Here it is. It's called the periodic table game. Play now. You've clicked play now. Proton Don wants you to play. There are 2 ways to play. What you're going to do is you're going to select game type, easy symbol, right? Click on the symbol easy. That was what was in the instructions. and then common elements medium. You're going to click on play proton Don, and it's going to ask you questions based on the periodic table. That's how you play the game. Does anybody have any questions as to playing the game or writing a discussion or making a poster? Anybody? If you have any questions, unmute yourself or type it in the chat. If you're all good, type got it, all good, fine, thumbs up, whatever into the chat so I know we're all on the same page, please. Excellent. Okay. All clear. Love it. Good, good. Yes. All right. Thank you, Casey. Good. Sí. Gracias. Good. Okay. Okay. Now, if I send something back to you, you can redo it, right? If it is an assignment, you have unlimited attempts, which means that you can keep handing in and you can add things to your poster. Somebody did that yesterday. I graded a bunch of posters from four out of 6 of the classes. And I already had the students send it back to me with the corrections on it. So they went from 28 all the way up to a 48 by just making a few corrections. So you guys can submit it as many times as you want to get the grade that you want. You can print the pictures case and that is fine. But, and you can type the information, but I'd rather you write it so that I know, because when I write something, it goes into my brain more so than me just copying and pasting. And again, remember, poster doesn't mean that it has to be a big poster. I said a piece of 8.5 by 11 piece of paper. Okay, so we're all good on poster. We're all good on quiz. We're all good on the game. Now what I need you to do, and you wrote in your agenda already. So now what I need you to do is take out your periodic table of elements, please. So on the back of the periodic table of elements, we already started talking about zinc. Zinc is our element that we started talking about. Zinc, if you can, type in the chat to me, please, and type it privately so I can see that everybody understands what I'm talking about. If you are looking at zinc, can you please give me the element symbol for zinc in the chat? Good, Addie. Yes. Aiden, go back and try again. Good, Tanvi. Jazz, yes. Ooh, me go back and try again, and I'll explain why in a minute. Lauren, go back and try again, please. Yes, me, that's right. That's fine, John, go ahead. Okay, good, 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 good. Go back and try again, Sage and Imena, please. Great. Kaysen, go back and try again, please. Yes, Aiden. Melina, go back and try again, please. And I'll explain to you why in a minute. Yes, Casey. Good, Kaysen. Absolutely. Jenna, try again, please. Lauren, that's right. Good, Katie. Yes, Jenna. Thank you. Okay. Oh, Don. I know you went to go yours. That's okay, Samantha. Thank you. John, try again, please. And I'll explain why. Imena, try again, please. Try one more time and I'll explain why. And I'll explain why using another element. I'm going to take element number, I think it's 28. Yeah, I'm going to take element number 28. Element number 28 is nickel. Don't type anything in yet. Nickel. And nickel, what I'd like you to do for nickel is to everyone privately, excuse me, send me the abbreviation for, or the element symbol for nickel. And Thomas, that's right. Yes, Tanvi. Good, good. Yes. Yes. What is the element symbol for nickel? Go back, Jazz, and look again. John, I'll explain it in a second. Jazz, yes. Yes, Aiden. Yes, Melina. Katie, good job. Me's got it. Yes, John, that is absolutely right. Good, Jenna. Okay, so the reason why, yes, Simena, the reason why I chose nickel is because some people, when they would type nickel, they type it like that, capital N, capital I. Now, if you look at capital N, capital I, that does not represent nickel. Capital N is nitrogen, right? Capital I is iodine. So you're telling me about two different elements. You're telling me about nitrogen and you're telling me about iodine. If you have an element where the first letter, where it has two letters, the first letter is going to be capitalized and the second letter will always be lowercase. That has to be always. So some people typed in a capital Z and a capital N, or a lowercase z and a lowercase n, and that's not correct. Element symbols, which is the abbreviation for that element, John, and I think you asked, but the abbreviation for that element is the element symbol. So what are the letters or letter that represents that symbol? Josh has his hand up. Go ahead, Josh. Joshua. Accident. Okay. John's got it now. Okay. So if I told you, I'm going to type in the chat, I'm going to tell you an atomic number, right? And you took notes on atomic number and element symbol and element name and atomic mass. Is that correct? Do me a favor, type in the chat the definitions that you wrote down for the periodic table so far. Did you write definitions down? All right. Okay. Oh, all right. I'll give them again because some people didn't write them down. Okay, here we go. Everybody stop typing in the chat. Here we go. Because you didn't write them down. This is really important. On the back of your periodic table, thank you, Tomvi. On the back of the periodic table, you need to write this information down. Okay. Okay, I'm gonna redo it because some people didn't write it down. So those of you that wrote the notes down, excellent. Just sit tight. Okay, atomic mass. No, atomic number. I'm sorry. Atomic number is equal to the number of protons in an atom, and it is also represents the number of electrons. Okay, now I didn't say electrons in an atom because the electrons are not found in the atom. The protons are in the nucleus, right? But the electrons are in this big orbiting cloud around the nucleus of the atom. So anytime you see the atomic number, that's going to tell you how many protons there are in that atom. It's also going to tell you how many electrons. The element symbol is the abbreviation for the element name. Now, sometimes you'll see the element symbol for sodium is Na, right? You'll always see sodium represented as Na. But sodium doesn't even have those letters in the name, right? What they're using is the Latin name for sodium. Yes, Tanvi. So like if I say, in one of the videos that I put onto your Canvas, they talk about iron. Iron is ferrous, right? So they take Fe from that to make it the element symbol for iron. So that's why they have different letters sometimes that you're like, wait, that's not even part of the word. It is, but it's part of its Latin word. Okay, so now we have the atomic number, the element symbol. The element name is pretty obvious, right? Beneath the element name is the atomic mass. The atomic mass is equal to the number of protons plus number of neutrons in the nucleus of an atom. Okay. Me what? Kason, Emmy. I don't understand your question, Kason. If you could try again. Okay, so the atomic mass is the number of protons plus neutrons in the nucleus of the atom. So we already talked about the nucleus. In the nucleus, we have two element subatomic particles, protons and neutrons. Protons and neutrons have the most mass. So most of the mass of the atom is found in the nucleus. That does not mean that electrons don't have mass, but the amount of mass that an electron has is negligible, okay? It's a very small amount. So protons plus neutrons are found in the nucleus of the atom, and that's what makes up the atomic mass. That being said, if you look at, and we talked about zinc, zinc has an atomic mass of 65.39. So that's a 65.39, okay? Now, whenever I talk about the mass of an element, I want to take relatively, yes, Tanvi, neutrons and protons relatively have the same amount of mass, yes. Electrons are negligible. They barely have any mass. Neutrons and protons have the same amount. Neutrons have a little bit more mass than a proton does. They don't have the same, but they have just a little bit more mass than the proton does. No, electrons. Electrons are negligible in the amount of mass that they have. Most of the mass is in the nucleus of the atom, which is protons and neutrons, right? So if I look at zinc, which is atomic number 30, and I look at the atomic mass is 65.39. However, when I'm asking you to figure out how many neutrons there are in the nucleus of the atom, we need to take that number 65.39 and we need to round it. And when we take that number 65.39 and we round it, we want to round it to the nearest ones spot, right? So the 6 is in the 10 spot, the 5 is in the ones spot. And then your decimal point is your tenths and hundredths. When you're looking at the number 65, we want to know what to do with the number 5 because we are rounding to the nearest one spot. So it's 65.3. That's 65.3. That 3 is going to indicate that the number 5 is going to remain the same. Anything that is 4 or less, let it rest. Keep it the same. If the number is 5 or more, you're going to do the chore. You're going to raise it 1, right? So I'm going to throw out a couple of numbers into the chat. I'm going to give you the time to respond to me, but I want you to respond privately, okay? You need to round it to the nearest whole number, the whole one spot, okay? So for example, if I type in 245.6, you would tell me, oh, if I'm going to round that to the nearest one spot, that's going to be 246, right? Because the number 6 bumps the number 5 up. Because 5 is the one that we're concerned about. 5 is the one that I want you to round. We're going to round to the nearest whole number, so it's 246. You could type in 246. Whoops, hang on. You can type in 246, or you could type in 246.0, or you can type in 246.000, right? All of those mean the same exact thing. If it's all zeros on the end, those are just placeholders. Yeah? Even if you typed in, let's say if you wanted to be silly, which I hope you're not going to be, I want you to type, you could type it in. That means the same thing as 246 because all those zeros are just placeholders. Yeah? I want you to round the numbers that I give you to the nearest ones spot. Okay? I'm going to type it in. There aren't there seven? There are 118, Aiden, on the periodic table. Okay. I'm going to type in a number. You are going to round that number to the nearest ones spot. Round that number privately to me to the nearest ones. Oh, no. Yeah. Okay, good. Yes. Yes. Good job. Yes. Yes, Samantha. Good. Okay, Layla, you need to round it to the nearest one spot. What is the 3 going to do to the 9? Kaysen, you went to the 10 spot. Aiden, you went to the 10 spot. Let's try to look at what's going to happen in the 1 spot. The number is 249.31, correct? So you need to look at the number to the right of the decimal. The number to the right of the decimal is a 3. That means that the 249 is going to remain 249. It's not going to go up to 250. Yes, Layla. Okay, let's try. Yep. Okay, good. Let's try another one. Ready? Remember, you're going to round to the nearest ones spot. So look at what's to the right of the decimal and see how it's going to change that 1 spot. Let's try again. Round it to the nearest ones spot. Yes, yes, yes. Lauren, you went to the decimal. I don't want the decimal. I want you to look at the 1 spot. The 3 is in the 1 spot. What's going to happen to the ones? Kaysen, it was 943.2, I think. What does the 2 do to the number 3 in 943? Does it stay the same? If it's 4 or less, you let it rest. If it's 5 or more, you do the chore. Yes, that's it. Good job. Okay, I'm still waiting to hear from students so that I've not heard from. Let's try Ronnie and Leslie
How
and
do you get into the quiz?
we're not doing the quiz yet, honey. We're just talking. We're just practicing things on the chat. Jazz, Melina, Carolina, sorry. Okay, one more. Yes, good, good, good. One more. Stop typing in the chat. Let's go. I'm going to give you one more number. You're going to round it to the nearest ones. Round it to the nearest ones, please. 397.51. What's going to happen to the 7? Yes, yes, yes. Good, Alyssa. Sage, Tavi, Samantha L. I'm looking, Aiden. Yes, yours is right. Yes, yes, yes. If I go back. Okay, Melina, we want to look at, you want to get rid of 5-1. You rounded it to 398. Get rid of the 5-1. We don't want decimal points. We only want whole numbers. Maddie V, if you look at it, I gave you the number 398. And it was 398.51, I think. No, it's 397. 397.51. All right, so stop typing in the chat. It was 397.51, right? If it's 397, the number to the right of it is a 5. 5 or more do the chore. is going to round that up to 398. Okay, so if I have 397.51 and you guys look at that, the number 5 is to the right of the 1 spot. You need to know how to do this because we're going to figure out how many neutrons are in atoms. Okay. Okay. I'm going to give you an atomic number. No, I'm not actually. Kason, do me a favor and tell me a number between 1 and 45, please. Okay, so what you guys are going to type in the chat, don't do anything yet until I tell you to. Okay, you have atomic number 36. To look for atomic number 36 on your periodic table of elements. When you find atomic number 36, you need to tell me how many, and do it privately. You need to tell me how many protons, you need to tell me the atomic mass, and you need to tell me how many neutrons. That's true. Okay, so what I'd like you to do is type it all along the same line so I know everything. So Lauren, you've got the correct abbreviation. Okay, good. But I'm looking for number of protons. I'm not asking what it is. I want number of protons, the atomic mass, and the number of neutrons. Your atomic mass should always be rounded to the nearest ones. That's why we were practicing rounding. Yes. Okay, I didn't need to know. Okay, let's take a break for a sec because I see some things coming in the chat. Okay, hang on. Let's do this one together. Stop in the chat for now, please. Let's do this one together. Casing gave us the number 36, right? For the number 36, many of you found out that it is Kr, which is krypton, right? But I didn't ask you what element it was. I want to know how many protons it has. How do I know how many protons it has? If I look at the atomic number always tells us how many protons are in that nucleus of that atom. So the atomic number is 36, therefore there must be 36 protons, right? Besides there being 36 protons, there are also 36 electrons. I didn't ask you that, but those number, it's always the same. What I did ask you for was the atomic mass. And maybe I didn't make it clear, and that's my fault. The atomic mass should always be rounded to the nearest whole ones number. So for krypton, the atomic mass on there is 83.80. If I take the number 83.80 and I look at that, in the 1 spot is the number 3. To the right of the 1 spot is the number 8. Will the number 8 change the number 3? If it's 5 or more, do the chore. 8 is greater than 5. So that means the atomic mass becomes 84, 84.00, 84, 84.0, whatever it is. So now we have the atomic mass. And earlier I said to you, and you should have written this down on the back of your ditto, atomic mass, yes, Kason, that's right. Atomic mass equals the amount of protons plus neutrons in the nucleus, right? Whoops, that should have been a plus sign, not an equal sign, I'm sorry. So the atomic mass is protons plus neutrons. Well, if I know the atomic mass of krypton is 84, 84 equals, do I know how many protons there are? I do, 36. But do I know how many neutrons there are? I don't. That's what I'm trying to figure out. So I can create a math problem where 36 plus n, and I don't know what n is yet, equals 84. If I then take the number 84 and I subtract from 80, whoops. If I take, don't type in the chat, please, 84, and I subtract from 84, 36, right? 84 minus 36 is going to give us the number of 48. So therefore, there are 48 neutrons in the nucleus of that atom, because in the nucleus are the protons and neutrons, right? And they make up the mass of the atom primarily. I said the electrons are negligible. They have a little bit of mass, but primarily the mass comes from the nucleus, which is protons plus neutrons, right? So if I know how many protons and I know the atomic mass, then I'm able to figure out by doing the math equation how many neutrons there are, right? Let's try again. I'm going to give you an atomic number. You need to tell me with that atomic number what the atomic mass is and how many neutrons. So let's take number 21. Take number 21. Find element number 21. Tell me how many protons there are, the atomic mass, and neutrons. Protons, atomic mass, and neutrons for element number 21. Look at the mass again, Thomas. Yes, Mimi, good. Yes, Aiden, very good. Lauren, look at element number 21 again, please. Scandium. And look at the numbers that are there. Good, Kason. That's the mass. How many neutrons are there? You need to round that number, please, Alyssa. Yes, Tanvi. Yes, Alyssa. Aiden, you got the number of neutrons wrong. I'm sorry. I went back to look. Remember, the amount of neutrons, you already know protons and you know the atomic mass. If you know those two, you can tell me how many neutrons there are. Remember, when you take the mass, Melina and everyone else, the mass is rounded to the nearest whole number in the ones column.
I have a question. Where is the periodic? I don't know.
You don't know where the periodic table of elements is? Okay, so Ronnie, what you're gonna have to do is you're gonna have to get in touch with your counselor. We handed out periodic table of elements when it was picture day a couple of weeks ago. I think that I do think that Mr. Cromie has copies of them in the library, or your counselor might have copies. What you could do is you could also look one up on the computer and print it out, or you can open up your agenda, and on page 141 in your agenda is the periodic table of elements. Okay, so there are multiple places to look. Yes, Samantha, love, you are correct with your answer. So I'm gonna go over number 21 with you guys. 21 is scandium, right? Scandium, the number 21 equals the number of protons, right? The number 21 also equals the number of electrons. The number on the bottom of that element box is 44.96. And the reason why we went over how to round is because you need to round the number for the mass to the nearest ones, right? Protons and electrons, for our purposes, Tanvi, for 7th grade chemistry right now, protons and electrons will always have the same with the atom. Okay? Okay. We'll talk more about that later, but for right now, we're going to talk about protons and electrons being the same as it is written on the periodic table. So we have in scandium, we have 21 protons, 21 electrons. Our mass for scandium is 44.96, but I don't want you using a decimal point. You're always going to use a whole number, and you're going to round to the nearest one spot. Because the number 9 is to the right of the 4, which is in the one spot, the 4 therefore becomes 45 because we round up. Okay, so now I know the mass, and before I wrote an equation, right? Protons plus neutrons equals the mass. Because I know that there are 21 protons, but I don't know how many neutrons there are, but I do know the mass is 45, I can write out a mathematical equation. It looks like 21 protons plus n, the amount of neutrons, equals 45 in total, the whole atomic mass. So then what you're going to do is you're going to subtract 21 from each side. And if I take 21 from 45, n equals 24 neutrons. Got it? If you're good, if you understand that, give me a thumbs up or an okay. If you don't understand, we're going to revisit it again. We're out of time for today. You will get more of this while you watch, while we go through the, good. Okay, guys, thank you. While we go through the module, it's going to remind you, and it's going to talk more and more about the periodic table and how the periodic table is laid out, and the protons, the neutrons, the electrons. We didn't talk about charges of each subatomic particle yet, but we will get there. All right, you guys are good. You know it's due Wednesday. You know it's due Friday. Friday, we are going to Kahoot. So come on in with your periodic table, right? And your Kahoot. We are on October break the week after that. So you guys don't have any assignments over October break. I just want module 5 completed. And I've given you only 2 assignments for this week. And one of them is playing a game. So you guys have a great day. Thanks for joining. And if there's anything that you need, I am just an email away.